Hello. Welcome to our presentation titled Efficient Solutions for Massachusetts Road Inventory Update Management. My name is Carl Hughes, and I am a GIS developer at MassDOT, the Massachusetts Department of Transportation. This presentation will cover a couple of tools that we built in-house to assist us in managing our statewide road inventory, which uses the Roads and Highways extension in a linear reference system. Before I start, I wanted to share a quick outline of our presentation today. I will start with some background on MassDOT as an organization and what we do in terms of road management, followed by the motivation for the tools we are discussing today. I'll then dive into each tool, giving a non-technical summary and demo highlighting the respective workflows, followed by a more technical overview of how each tool is created. We will then wrap up with a brief discussion on the benefits that these tools provide and the next steps in improving this process. MassDOT is the state agency responsible for maintaining the statewide road inventory. The GIS services team is primarily responsible for overseeing the technical process of this responsibility. We leverage the Esri Roads and Highways extension to maintain the network in an LRS system. Our route network spans almost 40,000 centerline miles, and we maintain attributes across 60 events, including things like jurisdiction or ownership, street name, and federal aid eligibility. MassDOT itself owns and is responsible for 3,000 centerline miles, while the 351 cities and towns across the state manage the majority of the rest of the network at about 30,000 miles. The rest is owned and maintained by various state and federal agencies or private entities. The mileage owned and maintained by local governments directly corresponds to the amount of funding that they receive annually from the state for infrastructure projects and maintenance. This is known as the Chapter 90 program. About 60% of the funding calculation comes from road miles, with the rest coming from population and jobs. It is therefore imperative that the road inventory is accurate and updated as changes are made, as real dollars are at stake for cities and towns within the state. Road inventory management falls upon various stakeholders, both inside and outside of MassDOT. This ecosystem has meant we need a multi-pronged approach to data management, beyond traditional RCEs or road characteristics editors and desktop GIS tools. At the end of the day, GIS Services assembles and disseminates the authoritative datasets, including the year-end road and bike inventories as mandated by the state. In the past couple of years, we've integrated our bike and ped data into the rest of our LRS as its own set of events. The folks who maintain those attributes vary from state and local agencies to regional transit organizations and are undertaken in parallel to the rest of the road inventory. The breadth and scope of activities required to maintain the LRS necessitates a centralized and standardized set of workflows for soliciting and tracking updates and issues to the road inventory from the various stakeholders within the overall ecosystem. Stakeholders have a financial and functional interest in providing accurate and regular updates to changes in the road inventory, and we, as the gatekeepers of this dataset, have a duty to be able to incorporate those changes effectively. Cities and towns rely on this data for real money, and colleagues within MassDOT, including right-of-way, maintenance, winter operations, and planning, need accurate data for everyday operations, and carrying out the transportation activities tasked to us as an agency. Additionally, the nature of this process is such that we need to be able to readily report on historical changes to the network. This means being able to identify dates, values, and supporting documents of proposed changes on an ongoing basis. Finally, we need to be able to do all of this largely within our existing technology stack and data processes. So how do we do this? Well, first of all, we created two parallel tools. Functionally, they're very similar, just configured for two different data sets. Those tools are RoadIE, or the Road Inventory Error Reporter, and BikeUR, the Bike Inventory Update Reporter. At its core, these tools are custom-built single-page web applications, built in React using the ArcGIS JavaScript and REST APIs, and leveraging ArcGIS Server, as well as an integration with our task management tool, Wrike. These applications were designed to be used primarily by non-GIS users in a standard and relatable map and form-based interface. The look and feel were designed to reflect the core of MassDOT's other web GIS tools, those used for data visualization and reporting of the same types of datasets. Now I will give you a quick demo of the RoadIE tool, followed by an overview of some of the technical details that went into their development. Keep in mind that RoadIE and BikeUR look and feel the same, with the only differences being in the key attributes used in the form. Okay, let's assume I want to report an incorrectly named section of a street. I would go to the RoadIE tool at this URL. I would then zoom to the location of that street in the map. In this case, a section of this road here. I'll click on the map to identify the specific route that needs to be updated by looking at the route number and the corresponding section of road that's being highlighted in the map. In this case, this is the correct route. And I know that I want to only update a specific segment, so I can attach from and to points to only identify the section of road that I want to update. I can then complete the form add my contact details so that I can be notified through Wrike and follow along as changes are made by the GIS team, as well as attach supporting documentation. When I hit submit, the edit is submitted to the database and a Wrike task is created, assigning the correct data people as well as the person who filled out the form. As a submitter, I can go into Wrike and I can view that task that was just created. I can leave additional comments and I can also attach additional documentation if needed. After a report has been submitted, the data team then takes over and makes the appropriate update to the LRS using an RCE or ArcGIS desktop as needed, based on the form submission and the comments section. The changes are not made automatically because we cannot rely on a one-to-one field to event attribute in this case. Once a submission has been approved or rejected and the edit is pushed to production, we have a script that synchronizes the update feature class using the status field from the Wrike task. The status of those edits can then be tracked using a separate dashboard that is used internally to visualize statistics on submissions from these tools. Now let's discuss some of the technical details of these tools. Again, the RoadIE and BikeUR tools were created in the same way, just configured slightly differently in terms of the events and attributes being referenced from the LRS. The front-end UI was created in React using basic JavaScript, HTML, and CSS. The two key React components are the map and form components. The tool uses ArcGIS JavaScript and REST APIs to provide the map functionality and calls back and forth with the related REST feature services. The specific route and segment geometries are returned using REST queries to a read-only route feature service, which has the LRS extension enabled. This allows for both measure-to-geometry and geometry-to-measure requests. The same extension is used to return attribute sets from events on the authoritative dataset. We use queries to the LRS-enabled service as opposed to a flat file because it is most often the case that a proposed update will span multiple segments of a route and/or start or end within a segment, which otherwise would be impossible to parse from a flat file. The form is then submitted as a feature to a submission feature service using the geometry of the selected route and attributes from the various form inputs. Attachments are enabled and added directly to the new feature. These requests are done using calls to the REST API. Once the report has been submitted and a feature added, a geoprocessing service is triggered that creates the task in Wrike. The GP service queries the data from the feature and uses the Wrike API to create a new task in the correct folder with the correct assignees based on the feature's contact attribute and our internal data team. And it also uses a customized Wrike workflow to add the proper tags, time frame, and status options. If the person submitting the report doesn't exist within our Wrike organization, the GP service will also invite them as a read-only collaborator who can also technically write and reply to comments for tasks that they have been assigned to. Adding the person who reported the update allows them to follow the status of the edit and provide additional details as needed. They're also notified via email of any updates or comments. Now we're going to talk about the Road Inventory Submission application, or RISA. So RISA is actually a set of two tools, and the primary function of these tools is to replace the previous paper-based process of local governments submitting updates to their road network to MassDOT in order to update their Chapter 90 funding. The two tools include an external portal which is accessed by GIS or public works officials from the cities and towns and is also a map and form-centric application. Access is granted via group management within our GeoDot platform. The second tool is an internal portal used by MassDOT's GIS services to review, approve, or reject those changes. Approved changes are pushed directly into our LRS without the need for an RCE. One of the key issues with the previous process was the sheer number of paper forms floating around. They were mailed to various people within MassDOT at various physical locations across the state in a variety of formats. It was also difficult to quickly and easily report on those updates, as well as follow up on the nuances and issues with specific edits because of delays in getting those forms to the right people. This is what the form used to look like, and one was required for each segment of a road that was being updated. The RISA tools were both built using Web App Builder Developer Edition. The core of the functionality comes from a tool called Geocortex Workflow, which is a custom web app builder widget that allows for highly customized and technical GIS-based workflows. We created a series of those workflows to replicate the paper form and add some significant improvements to the submission process in terms of directly editing and integrating with the LRS and related events upon approval from the internal tool. First, I will give a quick demo of the external tool where submissions come in from, followed by the internal tool where they are reviewed. Now let's assume I work for a town who recently constructed a brand new road that should be counted towards our Chapter 90 mileage calculation. This is the workflow I would use. I would navigate to the RISA tool, sign in with my credentials through GeoDot, you can see the application in the splash screen. Complete the rest of my details here. Identify the town that I want to submit the new road for. If I'm doing multiple roads, I can attach one document, or I can attach one document per road, which I will do. I need to fill out the road's details, attach the correct documentation, draw the geometry of that road, if I want to be more descriptive, I can describe the from location and the to location here. Complete the form. All of these fields are required as per the original form. This is just test data for now. These fields replicate the domains and field types for the specific LRS events that they will eventually be written to. Make sure everything is complete, and when I'm ready to submit, I can hit submit, or I can add an additional road or an update for an existing road. If the form is not complete, it will validate it for me. And I'll then receive an email once it's been received. Once it is time to review all RISA submissions for the year to update the road inventory, someone from GIS Services will go to the internal RISA website, which does require special administrative credentials to sign in, which I currently do have. I'm then presented with a list of towns with any pending changes, and I can also see any changes that were already approved or any that were already rejected. So in this case, let's take a look at the submission that I just made. Zooms to that street. I can then go into the review step. Now I'm getting this error message because route doesn't actually exist in our LRS, and that is the one step that does need to be done through ArcGIS Desktop. Once that route is created, it will allow me to approve or reject it, but you can see there are no buttons to allow me to do that at the moment. So I'm just going to leave a comment, save it, and then I can go back and review some updates that were left. So this town has several road updates that are pending review. And a road update can be done without any steps done in desktop because the route already exists in the LRS. So I can see that this update is for this segment of this route, and the attributes that are being updated is jurisdiction, and then street name also shows up by default. Depending on the attributes being updated, there are some other attributes that are hidden from the towns and cities, which are based on some decisions, some logical decisions within the attributes. So in this case, facility type and mileage counted need to be set because the jurisdiction is being set to city or town accepted. If I'm happy with this, I can choose to approve it. If the documentation doesn't suffice, I can reject it, and I can also leave a comment if I want to. In this case, I'm just going to leave it as is, but if I were to approve it, it would update the jurisdiction event in the LRS, and you would see that symbology reflected instantly. To summarize, the RISA external tool is used as the submissions portal for cities and towns to add updates and new roads to the road inventory. Those submissions are then reviewed inside the internal RISA tool by MassDOT. Both of these tools work using workflows created in Geocortex Workflow, which I will now quickly take a look at. Both workflows combine a series of forms and calls to the LRS map services as well as the RISA feature services in order for those edits to be retrieved, saved, and applied to the LRS. This is the RISA external workflow that is used in the RISA external portal. It's a series of forms and form elements where user-defined values, change and load events, and decision trees determine where in the workflow is executed next. Submissions can either be for new roads or for updates, and depending on what the user selects, the logic is different. The forms use fields and event values coming from the LRS enabled map services, and decisions here determine, and user actions here determine what to do next within the workflow. The external workflow is drastically different from the internal workflow. Which is much more simple, whereas this workflow here actually directly edits the LRS events upon approval from MassDOT GIS services, which you can see in here within this sub workflow, verifying value changes and requiring confirmation, updating features, and that kind of thing. So again, decisions by the user determine which section of the workflow get executed, whether that means accepting or rejecting, and so on. These workflows are added as custom widgets to the web app builder application, which enable the form component within the RISA tools. Thank you for following along. Before I wrap up, I just wanted to highlight some of the key benefits we have gotten out of these tools. First, they have significantly reduced the amount of paper forms as well as email and phone communication needed to report changes to the road network. These tools channel updates to our authoritative database and road network in the LRS. They also get to the appropriate data coordinators and analysts who are best positioned to make changes and review those edits. The paper trail that is created also allows us to report on changes to the network over time. These changes are important to track as we can quickly and confidently answer questions that we often receive from towns or other stakeholders about the status of certain changes. The changes are also based on one authoritative dataset, something that could have been siloed previously, with each user or town relying on different snapshots of the road inventory. Finally, I think these tools have increased the level of cooperation with municipalities by providing greater transparency into the Chapter 90 process. There is also a certain degree of leveling the playing field for small towns and cities who might not have dedicated GIS groups. This ensures they are able to participate in the process and ultimately provides fair distribution of funding. Thanks again for watching our presentation. If you have any questions or comments or are interested in a more detailed demo, please feel free to email us or visit GeoDot.